tutorial, I'd like to show you how to create a WebSocket API service using API Gateway from AWS. But before we get there, I'd like to walk you through some basic concepts of API Gateway, how to create basic API service, how to deploy it, and other small things which might be useful for us during this small tutorial. So let's go ahead and create a basic API which is going to use some mock data as a response. So search for API Gateway service. As you can see, there are several options to choose from: HTTP API, WebSocket API, REST API, and private REST API. In our case, this is going to be a REST API. Let's go ahead and build it. Welcome to Amazon. Okay, we're not going to import anything. We're going to create a completely new API from scratch. Let's call it Hello World API, lowercase. Create API. Once the API is ready, we can attach some resources to it. The resources in this case are the endpoints, which are going to be requested by the end user. So let's create a new resource. Let's call it Hello World. Hello World. Let's name it also Hello World. Hello World. And once the endpoint, the resource is ready, we can attach some methods to this resource. So we can choose from this list of methods. Let's choose the post one. And when the method is ready, we can integrate all the incoming requests with some handlers like Lambda function. We can send the data to another HTTP endpoint with mock data, with other services. And let's, in our case, for this basic thing, let's use some mock data. And once this is ready, you can see the whole flow of the request from the client to our integration endpoint, which is going to provide back some mock data and responding back to the client. And you can go ahead and test this endpoint if you have any get parameters, if you have some payload request needed in your request, you can fill it in here and hit the test button. As you can see, in our case, there's no data. The response is completely empty. But let's go ahead and add some mock data, some hard-coded data. So in mapping templates, application JSON, that's our type. And here let's add our JSON message. Hello world from API mock. Save it, go back, test it again. This is all the data from the previous request. Let's hit the test button once again, and we can see the message hello world from API mock. So it works. But the question is how we can request this endpoint, this API service from a real world application. So before getting there, we have to actually deploy this service. So let's deploy this service. We have to create a new stage. This is like your environment, test environment, acceptance environment, production environment also can be defined here. And let's call it test environment. And the version of our application is going to be 1.0.0. Deploy it. Once it's deployed, you can see in the stages in here, you have your test environment and you have your endpoint with methods. And when you go into your test environment, in here you can see also the deployment history. All upcoming deployment versions will be listed here, so you can easily switch back to the previous version if you want to roll back, or you can choose which version to keep on this environment at the moment. So in our case, at the moment, there's only one version, it's 1.0.0, which we recently deployed. This is the endpoint which can be hit to request the data. But pay attention, this is the test environment, and in our case we have to hit the hello world, so it should be hello world at the end. Let's copy this link and then let's go in the Postman, creating a new request. In our case it should be post method because it chooses to integrate with the post method, and send request. Message response is here, our response. So that's how it works with the mock data. Quite simple. In the next videos we're going to upgrade this API to use the Lambda function. In this video, I'm going to integrate our API service with a Lambda function. So first things first, let's go ahead and create the Lambda function. Let's go to our AWS, search for API Lambda function, create a new function. Let's call it hello world Lambda, and the runtime, let's keep it Node.js, and for let's create a role within basic Lambda permissions. It takes several seconds, so be patient. It should be ready soon enough. And once it's ready, scroll down. You can see in the editor code, in the code editor, the dummy code, which is enough to test our integration with the API service. So let's update this and make it, let's hello from Lambda WebSockets. WebSockets is not actually a WebSocket, it's going to be a REST API. Let's call it REST API. And don't forget to save it. Once it's saved, we can go back to our API Gateway. That's our API. And let's add a new method to this endpoint, to this resource. Let's create a get method. Get, save it, and let's integrate it with the Lambda function. So let's select our hello world Lambda, save it. And yes, we give it the permission. And you can see the same flow from the client, the same flow of the request coming from the client to our Lambda function, and everything what Lambda returns back, it goes as a response back to the client. So let's go ahead and test it. Test button, and you can see hello from Lambda REST API. So that's our message here. And if we go back, if we deploy this version of API, we have already the stage environment. Let's deploy the version 1.1.0, deploy it. We have our endpoint. As I mentioned before, in the history you can see the versions, so we can switch easily between the versions. But let's go ahead and test our endpoint. So check it, go here. That's our post method from the previous video, and this is our get method. Hello from Lambda. Everything is in there. So quite easy. In the next video, I'm going to create a WebSocket service already. We're going to upgrade this API service to a WebSocket service, and we'll try to connect and send some messages to the WebSocket API. In this video, I'm going to create an actual WebSocket API. And this API will handle the incoming connections from the clients as well as the incoming messages. And for this purpose, we'll need two Lambda functions, one for the connections and the second for the messages. So let's go ahead and create these functions. So Lambda, create new functions. Let's call it on connect. Let's use the default value. Runtime is going to be Node.js, and we'll create a new role with basic Lambda permissions. It takes us a while, several seconds, to create this function. That's how the AWS works. And the basic code generated with this function, it's enough for us to handle the connections. We actually don't need it at all. And let's go ahead and create a second function on message. On message. The same runtime, the same permissions, new role, create a function. And let's go ahead and update a little bit the message coming from this function. Hello from WebSocket Lambda to make sure we see the response from this code, from this function. Save it. Let's go back to API Gateway and create our WebSocket API. So create new API, make sure you select the WebSocket API. Let's call it WebSocket Server. The route expressions, in my case, it's request body action. I'll show it at the next step what's the meaning of this route expression. Request body action looks okay. Let's go next. And as you can see, it looks slightly different from normal REST API service. The difference is that the REST API has the resources and the methods attached to those resources. So based on these resources and the methods, we know how to route the incoming requests to different. So through those endpoints, we can go route the requests to different Lambda functions, to different AWS services, mocks, and so on and so on. In this case, there's only one single endpoint for WebSockets, which is used only for connection and for all the messages. So using this route expression, which I defined at the previous step, I can route the incoming messages on different handlers, on different routes. There are also 3 default routes handlers defined in here already. So connect is the one used for connection. Let's use our Lambda for this thing. On connect, save it, okay. And it works slightly different, so it's quite slow. We have to go back and forth, and we can see the flow of the request, of the connection request to the WebSocket server, from the client towards our Lambda. The Lambda is not responding back with anything to the client. It just says that the connection is established, and that's it. So let's test this thing. We have to deploy it to a new stage. Test in environment version 1.0.0. Deploy it. Copy the WebSocket URL. And I have a small application which allows me to connect to a WebSocket server. It displays the status of the connection. There's an option to send a message to the server, and all the incoming messages from the server to the client will be listed in this block. At the moment the list is empty. So let's connect to the server. Connect. The connection is successfully established. There are no errors in here. You can see it's green. Everything works fine. But let's try to send a message, and it should fail. Test message 1. It should fail because we don't have any handler to handle at the moment any incoming messages. So as you can see, this is my message, and this is response from the server, and this is the response from the server. And in my case, as you can see, in this case the action is on message. So I need this on message to define my route for this action. So it's on message. Define the new route expression here. And I'm going to integrate it also with the Lambda function, which was on message. Not this one, on message. This. Save it. Okay, we give it the permission to invoke the Lambda function, and it should be done. And it's the same flow, one-way flow. And let's deploy the new version. Deploy test environment 1.0.1. It's ready. The URL should be the same. Let me refresh this page and connect again. Connection successfully established, and test message 1. And there should be no, I think it takes a couple of seconds to update. So it's ready. There are no errors for all the messages. There are no error coming back from the server, which means the message is handled by that Lambda function. And we can actually go back and attach forcibly a response. So add integration response for on message. Come on, let me remove this disconnect because we don't have it defined yet. Delete the route, delete on message. We can add integration response forcibly everything what Lambda function returns back. Right now we'll go back to the client as a response. And let's deploy this new version. Test 102 deployed with the same URL. Refresh the page, connect again, test message 1, send a message. Again, it takes a couple of seconds to redeploy this application, and send it again, and you can see, as you can see, there's hello from WebSocket Lambda, which is our Lambda function. So every time you send a message, the Lambda will reply back with this response, and this response is coming back because of our forcibly attached integration response. So that's pretty much it, and in the next video we'll upgrade this WebSocket service to handle multiple connections and to share the data between the connections pretty much the same way like a chat works. When one client sends a message, all the other connections, all the other clients will receive that message. So in the video I'd like to upgrade the existing WebSocket service API to handle multiple connections and share the data between those connections. So shortly, one client is sending a message, all the other clients connected to the same server will have to receive that message. Pretty much the same way like a chat works. Someone sends a message in the chat, all the other participants in the chat receive that message. So first of all, I won't need this integration response. The Lambda won't respond back right away to the current client. We'll have to send that message coming from the client to all existing clients. So let's remove this integration. And the second thing which I need right now is to store somewhere the existing connections. So all the clients connected to the server should be stored somewhere. And I'm going to use DynamoDB for this purpose. For those who don't know, DynamoDB, it's a NoSQL database from AWS. And I'm going to create a new table called messages. Partition key is going to be connection ID. This is going to be my connection ID, WebSocket connection ID, and create the table. While the table is creating, I have, by the way, to add some permissions to our lambdas in order to write into the database. So I'm going to the lambda functions, existing lambda functions on connect. I'm going to the permissions. I'm finding the row which was created with this lambda function. And I have to attach new policy called DynamoDB. I'm going to provide a full access so it can actually read, write, scan, delete from the DynamoDB table. For your production application, you should be very careful with this thing. You should provide only the right level of privileges. For this tutorial, I'm okay with this because I will delete anyway after this tutorial ends. So attach this policy. I have to do the same thing for the other lambda. So for a message, when someone is sending a message, it will have to go to the database, to scan the database, to retrieve the list of connections, and to send that message to all the existing connections. And in order, by the way, in order to send from the Lambda to call the API and send the message to all the connections, it needs another right privilege called the invoke API, invoke gateway, API gateway, invoke full access, this one. Attach the policy. And I'm going to create a new lambda which will handle these connections. So when one client is leaving, is disconnecting from the server, that lambda will have to remove his connection ID from the database. So let's actually go ahead and create this lambda function, kind of function called on this connect. The same thing, Node.js, create a function. And when the function is ready, I'm going to add the same permissions to delete from the database. I'm going to add the full permissions, but it should only have actually normally the delete privileges. So DynamoDB full access. And here I think you can actually define your role only for delete. No, not this one. It's well, for the table that it should have only delete privileges, but I'm going to attach anyway the full access. So attach it, attach the policy. So it's done. And let's go and update the connect lambda. So lambdas connect, and then here I'm going to use the right code. So on some connects, all the code, by the way, which I'm using here will be on my GitHub, and the link will be in the description of the video. I'm going, and shortly what this code is doing, everything starts with the handler. It retrieves the current connection ID from the WebSocket event, and it's adding that connection into database via this function. So this is using the DynamoDB API from AWS SDK from npm, and it's putting a new record into the table called messages with the item connection ID, which is coming from WebSocket as well. And we have to save this one, and I think we can go ahead and test this thing. And let me open the DynamoDB database to make sure we don't have anything in there. Tables, messages, items. So the table is completely empty. And right now, when I'm going to connect to this server, let me grab the URL for the WebSocket server. Stages, my test environment, connect, successfully connected. And right now in the DynamoDB, I should see one connection ID, this is one. Let's create the disconnect handler for my API gateway, which will actually remove the connection from the database. So I have my Lambda function ready on disconnect, save it. Okay, we give it the permission to invoke the Lambda function. It should be ready, the same flow. Let's go into the Lambda function and update actually the Lambda function itself to delete the message. So the code is pretty much the same like on connect. The only difference is that in here is deleting. Instead of put, it deletes from the table messages, it deletes the connection ID coming from the WebSocket event. Let's save this one. Let's go back to our API gateway, and we have to deploy the new version. Test, let's make it version 2.0.0. Deploy it. Grab the URL. Let me go to DynamoDB, make sure we don't see any items in here. Let me remove it. Delete. And right now when I'm trying to connect here, connect, successfully established, I should see an item here, and when I close this thing, the client, I should see no connections in the database. So let me refresh, it's empty. So on connect and on disconnect, both Lambda works fine. And right now I have to define the next Lambda, which is on message. When someone sends on message, I have to scan the database to grab all the connection IDs from the database and to send that message to all the connections. So let me go ahead and update this code on messages. What this code is doing shortly, as usual, is everything starts with a handler. It initializes the API Gateway SDK, so with my domain name and my stage, which is test environment, and the API version, which is this one, it's default for the whole AWS SDK. After that, it's preparing the message in JSON format, which will be sent to all the connected clients, and it retrieves from database the existing connections via this function scan. It's scanning the table name messages and returns a promise, and in the promise it will return an items of connections. I'm going through each item, I'm receiving the connection and sending the message to each item. And since it's posting to the existing connection with the connection ID, the data, which is in my case the message. And that's it. That's pretty much it. Quite simple. Let's save the code and let's make sure, well, here there are no connections in the database, and let's go ahead and try copy link. Let's try to initialize several connections. Let's make 3 clients. So this is going to be client 1, connected. Let's duplicate this tab. It's going to be client 2, connect. This is duplicate, will be client 3, connected. And right now, let me show you all the messages. Let's say the client 2 when sends message from client 2, it sends a message. It received, the same client received his own message, and I expect the other clients to receive the same messages as well. So as you can see, message from client 2, message from client 2. And let's send message from the client 3, message from client 3. The client 3 should receive its own message, which is okay. Right now he has 2 messages, one from the client 2, another from the client 3, and the client 2 should have also the message from client 3. Client 1 didn't send so far any message, but he received both messages from client 1 and client 3. So it's kind of a chat. So message from client 1, send 1 message, 2, 3 messages from client 1. Right now client 2 should have 3 messages from client 1, and client 3 should have 3 messages from client 1. So it's a chat, it works. So that's how WebSocket Service API works on AWS. So that's it. If you have any questions, feel free to leave a comment, and wish you good luck with this thing. Bye.